And the shop was wait for others to join. You can, if having doubt regarding the assignment number 3, you can ask me now. You can discuss. such a join. Till then, we will discuss about earlier. So, which are the following statements are the first question of this assignment? Which are the following statements are true for Bernoulli? So, the Bernoulli process, Bernoulli trial consists of repeated trials of trials with replacement. Yes, Bernoulli trial consists of repeated trials with replacement. Bernoulli trial consists of a single trial. The outcome of the Bernoulli trial is either success or failure. That's true. Expectation of the Bernoulli random variable in the random variable that the random variable equals. So, what do you think the answer might be? And not repeated trials. This is not true because Bernoulli trial means we are talking about only single trial. So, you can stop only single trial. So, this is not true. Outcome of the Bernoulli trial is either success or failure. Yeah, that's true. Because like flipping the coin, these things are like either a success to the result or failure. Success is generally given as one, failure is generally given as zero. So, fourth one is expectation of the Bernoulli random variable. The probability that random variable equals probability. So, if you try to find the expectation of the extent of right? So here we have x of 0. In this case, x if you put 0 into p of 0, 1 into p of 1, what we are getting is, let's don't give the value of probability, let's keep it as 1 itself. So 0 equal to p. Uh, but if you are taking this to be, then we can write this expectation that Case also if there are P. So expectation of the Bernoulli random variable probability. Random variables equals 1. So we expect if the random variable equals 1. So it results in probability of the random variable. So fourth is also true. The next question is not in the current and but it's just from the previous assignment. This might be helpful for you to whether similar questions might come in the exam. So this we will discuss. In Bernoulli trial, the two random variables that indicate success and failure in the trial are denoted respectively by values 1 and 0, and then 0 and success is 1, failure is 0. We have discussed. So only two outcomes are possible for each trial, success or failure. So there are characteristics of an trial. The trials are indefinite. So outcome of one trial does not affect the outcome of another trial. Each trial is independent of others. Then probability is fixed. Probability of the remains constant for each from each trial to trial. Which means like if I get one success in one trial, like if I get a fail in task doesn't affect the next task that required is. So answer is either one and zero. The property for the binomial distribution is mentioned. So the following property hold binomial distribution. The options are the random experiment consists of m Bernoulli trial. And then each trial reversing to outcomes either one or zero. It is called binomial because each trial experiment has only two outcomes distribution called binomial expansion. Probability of success in each trial is constant. So let's take a minute. Let's think. So it's a random experiment, Bernoulli experiment, and it consists of n Bernoulli trial. That can be so that is, each trial results in two outcomes, either one or three. That is that we have seen before two questions. It's true. It is called binomial because each trial in the experiment has only two outcomes, and distribution follows binomial expansion. This is also true. So the probability of success means trial is constant. This also we discussed in the previous question. It's the characteristics of the binomial experiment or binomial trial. The same applicable for the characteristics of the binomial distribution. All are towards in percentage. What are the key characteristics of binomial distribution? So binomial distribution for each trial only two outcomes must be distinct. Fixed number of trials is fixed in our field. Like you will tell like this one only we are going to perform and this one in number of opinions. And each trial is independent, which means the result of the previous trial is not going to affect the result of the upcoming trial or the subsequent trials. The probability is constant. Probability of success P remains constant from trial to trial. These are the characteristics of binomial distribution, and that is PM of probability mass function replicate. Uh, yeah, factorial. P power half factorial. P power factorial. Sorry. C N C R the P power R and P power n minus R. So NCR can be written as F factorial by by- by- This is a probability loss function. If we tell like R is the number of success or number of failures, it depends like based on our desired problem. So for example, if I have thrown 10 times dice at the same as equal to 10, you tell like I want to get 6 times the 6 times 3. So yeah, we are expecting 6 times to have the 3 to have. What is the probability of getting 3? 1/6. Then what is not probability of it getting 3? 5. You solve this, and also this binomial distribution changes with respect to number of times. So if you see here, right, so initially with only 20 um, population, the binomial distribution this is skewed towards the left. Then, as we keep on increasing the binomial distribution, it approaches standard normal distribution. This is evident from this, right? It looks perfectly like a standard normal distribution. When at the center of the standard deviation, like central limit here. So we will try to understand what is central limit here. For the data I doubt the previously discussed section, we can discuss. If you have any doubts. increasing. We have seen visually that it increasing the number of hairs. Uh, Distribution, dynamic distribution is approaching towards the normal standard of distribution. So you can also see from here, either normal distribution includes like random distribution. With increase in sampling size more than 30, it tends to the standard normal distribution. So that is a central limit theorem. Sampling distribution of sum or average tends to approximately a normal distribution of sample size increases. So let's see this problem number 8. I'll be shuffling it because based on the topic what we're discussing. So don't be alarmed. If you have doubts, you can stop me. The better you can this. Okay. So which of the following statement is correct one in central limit? Sampling mean the population mean is equal to the sample can deviation what is from the people. Sample size is large and the mean of the sampling follows the normal distribution works. Important difference. Here, the sampling and population mean may not be equal. They might change with respect to number of samples. So, and sampling standard deviation, population standard deviation can never be equal, as you can see. It's increasing number which it changes with the, for example, if we take a okay, then obviously the standard deviation is produced to not so if the sample size is large, the mean of sampling for the normal distribution approximately. So this is what we have seen that with increasing number of samples, the sample size it approaches towards the standard normal distribution. So making the central limit. The experiment is conducted and outcome is set to follow the analytic. Which of the following statements are about? Take a minute to guess. This question was much earlier along with the economic level, but somehow I extended it up. So first you will see the options. Outcome may consist of true or false. Okay, the outcome could be true, false, or not true. There's nothing like not found. Yes, they're not correct. There's only two outcomes which we consider. True, false, one is zero, defective, non-defective. Okay. This is also not true because zero one should be. Results won't be going like that. The outcome is either zero. No, also it outcome could be defective, non-defective. So like the doctor we can so one is correct, but one is correct. So you want to hold the customer that about 65% of popular bank. Customer decided to take for the problem that is to one of again. It's distribution. It's maybe able to go this. and this small. Like only 10 plants, but um, the L value is very high. Then it will be difficult to do a binomial distribution. So that can what we should do is Poisson distribution. Should be discussing in the subsequent slides. So here in this case, so we have shown like probability of the papaya being fruit bearing is 0.5. Then you zero three. This why is asking what the probability that is one at least one means we have to start with 1, 2, 3. Okay? Then this will become a big problem. Like you have to start finding from 1 to 10. So it's easy. It is like what is the problem? But it like the you know the over or SP 0.05 you use twice for enhanced output. Cancer and become one. This is again one. Then 0.35 for 10 is like 0.7 10 to the minus 1. With the answers should be closely related to this, which is 1 minus that's 1 minus stand for the correct answer, and it is the case of binary. So there are two correct answers. Two answers for the same question. Yeah. This we are signing off to this binomial distribution from here onwards. Why atomic distribution? We have it. Yeah, that's right. Poisson distribution. Poisson distribution is limiting form of binomial distribution with the number of trials being large, with probability of success being very small. So number of trials is large and probability of success is not n is tends to infinity and p tends to zero. So in that case, we will be using the Poisson distribution, and it will in that case only the Bernoulli distribution will be transformed into Poisson distribution. Okay, the Poisson distribution can also be approximate the binomial distribution and number of trials is large and probability of success is small. So that's what we have discussed, right? It deals with average rate of occurrence of the. So the probability mass function is given by f of x lambda power x the e power minus lambda divided by x factorial. So how this works is like when we use this is like if you have some average 10 number of frequency is like 10 per given time, like that if you discuss and what is the expected frequency, like what is the probability of getting x number of occurrences in given time, like that if you deal with, then we will be using Poisson distribution. Deals with the rate of occurrence of the event. We can see here the binomial distribution consists of n trials and p as a probability of success can be approximated by a Poisson distribution when n tends to infinity irrespective of p, n tends to infinity and p tends to 0, p tends to 1 irrespective of n, p tends to the here n is the n and p all matters. So as we discussed, n tends to infinity and probability of success tends to this is very small, which means it tends to 0. That is the answer. For example, a pizza delivery service having average rate of even like restaurant received an average of 5 pizza orders per hour during peak time. So lambda is equal to 5 pizza per hour, and you can calculate the probability of receiving a specific number of orders in an hour. So what you're receiving specific number of orders in an hour is like if I tell what is the probability of getting 3 orders in an hour, like that. So when during the lunchtime rush hours, there might be a surge in order. It may exceed 15 or 20 pizza per hour also, leading to higher refrigerator volume. And late at night, the orders might decrease, the getting lower. So we should know like what is the trend or how the average what is the requirement is, and based on that we have to plan our human resource, plan our raw materials, everything. So for that, this will be helpful. And if I want in between, for morning, for afternoon, for night. So morning it is very less, afternoon it is relatively very high, then late night it is very less. So with this, for the evening time, it is very high. If I have this data, if I want to find it and then wait the morning or like before the after, what is the probability of before the like this we can estimate if we know the trend. Okay, so this is where it is very helpful. We can solve one problem so that we will get more clarity in this particular aspect. So first, one this question is: it is known that each steel slab produced by continuous casting has 5% chance of having infection. So probability is very less that because defects means we should have a very low probability, low occurrences, right? Otherwise, the production process itself will become very loss. So P is 0.05. If sampling of slabs is done randomly, what is the probability that out of 100 slabs selected, exactly 4 contain an inclusion? So out of 100 slabs selected, 24 contains an inclusion. This is what we are going to today we are going to discuss. So N is very high, 100 slabs, and only 4 contains that. So we have to find what is the probability only 4 contains that. For that, we know N is 100, which is 4. and lambda can be divided by n x p. But p is the part. So lambda is n, and so the lambda is with this, we know the probability mass function for this. Um, e power minus lambda e power minus 5 into lambda power x. Lambda is 5 power, lambda is 5 power, occurrence is 4, divided by 4 factor 4 is the thing. So when this, if we calculate, it is 0.1. This is the answer to this question. So geometric, with this call of the Mongolia distribution. If you have any doubt, you can ask. Distribution is a probability distribution that models number of independent ordered trials required to achieve the first success. Like 10 number of trials are required to achieve the first success. Like it is often used to describe the number of trials needed before observing a particular outcome. Can also be not only success, can also be the failure. Number of trials needed before first failure, such as first success, is the correct solving. Okay. So the characteristics of this geometric distribution are it involves the sequence of independent trials as like the Bernoulli trial. Each trial has two possible outcomes as like Bernoulli. This possibility, because we are discussing the Bernoulli, right? So that's what the probability of success remains constantly on the trials. The distribution is Bernoulli's, meaning past trials do not affect the future. So these are the major characteristics of this particular distribution, probability distribution. And one key thing which you have noticed here is the lack of minus property and probability of success. Probability of success remains constant across the quantifiers. Because in future, one more distribution will be considering. In that, the probability of P changes. So, because it is like here it is with replacement, that is without replacement. There is nothing but the hypergeometric distribution. When we are discussing that, we can discuss in detail. So, here, certain things which you have to know is like probability of x equal to n is given by b into 1 minus b whole power n minus 1, and b of x greater than n is given by 1 minus b whole power n. So mean mu is natural mu is 1 by b, and variance is given by 1 by b divided by t square. Okay, these are all the parameters which we will be estimating under the respective relations. Okay, so these are probability of success and the number of success first successful trial. I solve the problem so that we'll get a better grasp of this particular topic. So in the whole example, what is the probability 50 slabs are sampled before the first inclusion is detected? So 50 slabs for the first inclusion. And the previous one is taking right. Okay, this problem. 100 slabs, the number of slabs are 100. So P is equal to 0.05. So what they are asking, number of trials for first success. Or the geometry distribution as you know, the probability 50 slabs are sampled for first inclusion. For this, we know probability is 0.05. And the number of slabs after success is yeah, so 50 and it's equal to 50. See, we get here it gets 1 minus b is 0.95. We don't know about whole power 49. So we solve this question. Okay, go to the next one. The n Bernoulli trial with random variables x equals to block trial to first successes. The n Bernoulli trial with without replacement. Um, sorry, with the replacement with random very equal first offenses is given by geometric distribution. That is like without with replacement, sorry, without replacement being hypergeometric distribution. In the picture. So with this, I think it should be clear. If you have any doubt with geometric conjugate, you can ask me. We can discuss on one further. is hypergeometric distribution. Hypergeometric distribution models the probability of obtaining a certain number of successes, usually not less k, in fixed number of draws, not less n, from a finite population without replacement. So here, the key thing which you have to notice is the without replacement and the fixed number of draws or without replacement. So it involves sampling without replacement. That's first major characteristic. Population size n is finite. It's not like the cases that is not discussed. Each draw changes the probability of success for subsequent draws. That is the key characteristics which is adopted from this without replacement. Typically used in situations where the population size is small, related to the number of draws, and large probability of success changes as items are. Okay. First major application to this is like we can consider atom core chromatography. Atom core chromatography is we have a tip of material and you have a detector here. So we will be ionizing using the laser, pulsed laser. We will be ionizing the sample atom by atom. So we can able to construct a 3D construction of that particular tip. Around to which position like can map it to three dimensions. So here, once when one atom, say atom is rejected from this, I will consideration of mass, the atom reduces n of a minus one. So then probability is not uh, depends on n of a. Now it depends on n minus n of n a n suffix a minus one. So it changes with respect to previous ionization. So this is the best example for this hypergeometric distribution can be used. Hypergeometric distribution can be approximated by binomial distribution. Okay, so a hypergeometric distribution can be approximated by binomial distribution when sample size is very small compared to the population size. The sampling done without replacement. This is the characteristics of the hypergeometric distribution. When sampling is done with replacement, then it becomes geometric distribution with sample size is finite compared to the population. So this is the characteristics of hypergeometry. The sample size is very small compared to the population sizes. The case we can consider the approximate the hypergeometric distribution as binomial distribution. So in 3D atom code, a small volume of gold is consisting of m atoms. Assume that J of these are type A and the detector of only n atoms were detected, of which 5 are type A. So what the power distribution of the kind of variable as we discussed before, it follows the hypergeometric distribution because it was a fixed volume and sample size is fixed and it is done with the probability of ionizing an atom is done with replacement. Probability density function of measurement of a particular material property is given by f of x. So that a certain order mathematical product is being the density function of a particular particle distribution is of the form f of x a by 5. So is a constant. Given that x is greater than 1, for the function to be period, k should be equal to from equal to 1 to infinity. So here for 5, if it tends to 1, then it is period. It's cumulatively. Some of them become some of the probability becomes 1. So that is what we mean now. So a into would be of power. So if we solve this, we can get the answer to this. So we can solve this. Integration of x is given by k to power 5 plus then k is given to 5. Um, it can be given by, you know, substitute the things, it will become 0 when x power minus infinity. So 0 minus the bottom minus will become make it black. So 4 x power 4 for the 1 is equal to that is the and that is similar problem where the probability density function to a particular material property is given by of x up to 2 by 3 of 3.8 it varies from 3.5 to 5 and f of is equal to 0. So what is the probability that the shared value between 3.5 to 3.94? Actually, okay, since here everything is defined above the 13 defined. So what we can do is directly we can find the probability. It's given by 3.9 to 4.1. Uh, f of x dx. F of x is 2 by 3. Just substitute the answers in this. So value of this. So replicating the answer there. So another simple problem. So I thought this really clear about PDF, how to solve the PDF problem, object density function problem, and alpha geometric distribution problem. Next is which will go with variable distribution. Label distribution is continuous probability distribution commonly used to model the reliability of lifetime automatic technical equipment, materials, or components. It is characterized by two parameters, the shape parameter and scale parameter. Scale parameters denoted as C and scale parameters denoted as alpha. So the probability distribution can be given by f of x is equal to C by alpha into x. C power C minus 1 by alpha into e power minus x by a into c. Cumulative distribution function can be given by f of s capital F of x is equal to 1 minus exponential of minus x by a into c. These are the characteristics. These are the relations. And what are the influence of the shape factor on the curves? So let's see that. So when shape factor is less than the distribution is skewed towards the left. As you can see here, it's skewed towards the right. Skew is here. And c is equal to 1. It will become exponential. And c greater than 1 skewed towards the left. Like, c doesn't want to be clearly failures. C greater than 1 depicts the zero failures. The equals of shape parameter. While scale parameter denoted by alpha. This determines the scale of the characteristic time. Larger the alpha element, longer the average time times. For example, if you see here shape parameter is given by beta and scale parameter by beta. So, this given scale parameter, if you change the shape parameter, it is changing from um, skewed one to normal distribution. My question is based on that. Assume that the fatigue brake from a steel sample under a constant load follows vehicle distribution. Shape parameter is the fluid and scale parameter is computed. Alpha determine the probability company last at least 80% accurate. The shape parameters too. When scale parameter alpha is 1 lakh seconds. And then they are asking you to the probability that steel sample is lost. Please, their fatigue reaction is 80% cycles. Or we found can be more than that. Oh, since it is at least, we should use the community distribution function. It's not an exact value. It is greater than the more than that, like that, it should be default. So can be given by since they are told at least uh, okay, given by uh, Here, K is scale parameter, which is 1 lakh sample. So it's two. So it is zero. Yes. Square whole C. So it is whole power. It's a power. Made a mistake. Yep. Going to the final question, which distribution shows a lack of normal problem. See, the log normal distribution depends on like when even progress and the probability changes, the distribution also changes. Hence, log normal distribution lack of number probability. Variable distribution uses the norm of average lifestyle scale and everything. So this also cannot be a backup property. Exponential distribution is done without replacement. So with replacement, and it's a discrete function. So this is the backup property. Again, like normal distribution, normal distribution cannot be exponential. So backup property. This which goes to the discussion distribution. U plus or minus 3 covers. What you see, one sigma means will cover the 8.26% of the 2 sigmas will cover plus 95.4% of the data, 3 sigmas it will cover 96.7%, so 10.70% of the report that plus or minus sigma. This goes this discussion. We have I further down. You can ask now, this is my mail ID. You can also mail the mail ID. You can ask questions. Also, you can press the question. So those are special.